All right, we'll get started here. If we kind of did we were asked to do a little impromptu presentation on 60 gigahertz and 60 gigahertz use cases. So when Tolly says, "Hey, can you do this?" It's like, "Yes, we'll do it." So we're going to get
about an hour and a half.
yeah, in about an hour and a half. Oh. So we kind of threw this together. It's going to be a little informal. I'm going to pick on a couple people here in the crowd on how they're using 60 gig, but we wanted to go through a couple slides here. We kind of threw this. I'm Justin Wilson.
I'm Justin Miller.
So there's the J squared up there. We kind of threw that together. So why 60 gigahertz? You know, small beam widths, mitigate interference, high bandwidth from point to point or multi-point. We're seeing WISP cell sizes shrink. You want more bandwidth delivered to the client. You want that higher modulation to deal with interference and things like that. And we're seeing more and more WISPs are doing small cell, you know, just like you hear with the cell folks. So what can you use 60 gigahertz for? You know, building-to-building connectivity where you can't, you know, dig up the streets. You need a gig from, or even we're seeing 10 gig from building to building. IoT is a huge thing. All these sensors out there, we're going to see these points where you have to aggregate IoT data. You're going to need high bandwidth for that because you have more and more sensors out there and they use more and more bandwidth. Events. One of my clients in Indianapolis, they're near Lucas Oil Stadium where the Colts play. They've had numerous requests for, hey, I need a gig for 2 weeks. You know, how can you get me a gig to a parking lot for 2 weeks? You're not going to run fiber. You're not going to run fiber across the parking lot. You know, 60 gig can reliably do that because it's interference free. So, you know, it just frees up that spectrum. And we're seeing more and more hybrid networks, 60 gigahertz on a pole, fiber fed, and then you're distributing it out from there. You know, we can allow layered services using 60 gigahertz. 60 gigahertz point to point for high bandwidth. You can layer on 5 gigahertz on that for maybe some, you know, point to multi-point for businesses or whatever you need. You know, something a little better than your standard, but you don't want to chew up that 5 gigahertz spectrum. So 60 gigahertz can deliver it, and then you can bring it the last couple hundred feet or something like that. And then we're seeing 2.4 gigahertz for mobile and IoT, your phones in downtown areas, you know, that sort of thing. So I'm going to turn it over to Justin Miller. He can kind of tell you what he's doing with. Did we make a typo somewhere? You should have caught that.
Yeah, I should have. So we do fixed wireless with 60 gigahertz quite a bit, and we have a fiber network, a few buildings on that network, and then we branch off from there using 60 gigahertz. So we've really found that we've been able to sidestep all the massive interference with 5 gigahertz. You do a scan on top of a rooftop, you might see 300-400 SSIDs up there, and 5 gig just doesn't work, and DFS is not very good for city. So 60 gig was a very good choice for that. We've got 58 LHD radios deployed right now and 38 WAP 60s. We've had really good success with those. So it's, so we have a graph here, a smoke ping. I mentioned earlier that we like smoke ping a lot. It shows you where you have problems, a lot of smoke here, 5 gigahertz network here, and then we move to 60 gig right here. Massive improvement. Oh no, sorry, this is 60. This is a 60 gig radio, and then we move to an LHG radio here. So the next one is 5 gig. Here's 5 gig latency, 20 milliseconds. Bottom end is about 10 milliseconds. And we switch to an LHG here. So it really improved.
That's a huge difference, isn't it?
Yeah, this is 360 days. So if we have any loss, it shows up as a blue line. But this, when you zoom in here, it's pretty green all the time. I think I have another view of that here. So here we have same kind of graph and the last 10 days of latency. This is from our data center all the way back to this building.
So how many hops are you going across here?
4, I think.
So four 60 gig hops.
No, this is fiber and then
fiber
and then 60 gig last leg.
Still not bad at all.
So recently, the 5th channel came out, which allows you to go even further with better signal strength. Right now, it's only accessible through the command line. You have to set up a scan list and on both sides, and then you can choose it. So you can see physical rate of 2.3 gigabits per second aggregate.
How much fade do you see on something like that? We'll talk about that in a little bit later, but
our longest link is 1.2 kilometers right now, and you have to be very, very good with alignment on those to not have any fade. So here's one of our buildings averaging about 100 and it's about 100 megs here, and then we sold an upgrade package, and someone was able to do a speed test for 600 megs there. This is Puerto Rico. This is you.
Yeah, I just put out a call on some of the WISP lists for some installation pictures. This is Angel down in Puerto Rico, so thank him for those pictures. He's doing a lot of point to point links. If anybody's ever been to Puerto Rico, there's a big mountain in the middle that separates the north and the south. So it's easy to get up on the mountain and do shots down into the bowls. Angel's on the south side in a little city called Ponce. Well, not a little city, but it's big. So he's using these. It's Puerto Rico. I don't know what rain region Puerto Rico's really in, but it's humid, and he's seeing very, very good reliability. What are you seeing in what rain region you're in? Or
I think we're in K.
Okay. Yeah. Here's another kind of like Miller shot here. This is one of his. It's kind of a little shorter shot, 363 meters. He's able to get 2.3 gig. His BHI rate. I mean, it's solid link for him. He's using it he's a WISP down there. So things we need to know about 60 gig. Affected by oxygen absorption. The beam, if you've ever aligned an 80 gig or even a microwave link, 60 gig is still wide enough to tune it in a little easier. I mean, maybe you guys can talk about what you've seen.
Yeah, it is pretty easy to tune. It seems to be about half a foot, beam width, and there's a sweet spot in there you can find sometimes.
We got a picture later. Stable mounts are key for anything, in this frequency range. Unlicensed in the U.S., so you can deploy it pretty much wherever. One of the nice thing about the beam width being so tight is you can stack these on top of each other. You can have several pointing off to various places, and you're going to mitigate your self interference by just using 60 gig. We always kind of follow the 3 foot, but there's been poles where they're almost touching each other, and the only reason we're not touching each other is we don't want the bleed over from the card inside the unit to affect the other one. Yeah, a foot would be sufficient. I mean, really, you don't have to worry about the beam at that point. You just have to worry about the RF from the card bleeding over into the other one. And there's enough channels where you can kind of get away from that too.
And we don't have to stack them because we have rooftops, so we spread them out across the roof. Yeah. So here we have a graph of the oxygen absorption, and I think I can't see any numbers, but
yeah, this is somewhere around the middle of the 60 gig.
60 is right in this spectrum right here. So when you're in the 58 gigahertz channel, the oxygen absorption is highest, and as you go up higher in the channels, it drops off pretty dramatically. So when you're in 66 and higher, it gets closer to 70, and that issue really goes away, and you can go further.
You were kind of mentioning it earlier about it's the opposite of 5 gigahertz.
Yeah, it's the opposite. So the lower the channel, the less less loss you have in 5 gig, but in 60, the higher the channel is the better one. So
you're getting away from the oxygen absorption of the 60 gig, because there's a tuning frequency where the oxygen kind of overtakes the signal. So the further away you get from that, the better your signal is.
There's currently 5 channels, and each channel is 2.16 gigahertz in size. It starts at 58 and ends at 66 right now. That's at 802.11 AD, and there's a new protocol coming out soon. So here we have a picture of, whoa, that's really big, but the original mount that came with the LHGs was okay, but it was really hard to do long links with it because it was just a U-clamp, and you couldn't do the adjustments independent of each other. So the quick mount came out for the LHGs, and that really helped us get really long links. And now we have the solid mounts here, which we're slowly redoing all of our links with this, because it's got really fine adjustment. So the future, we've got 802.11ay, which allows channel bonding. So we're going to have multi-gigabit over the air with that. And I think it's going to go up to 68 or even higher.
So one of the things we want to talk about here is use cases. So you're mainly an MDU.
Yes.
So tell your typical customer.
Our typical customer is a property developer, and they want to provide an amenity in their units. So we do a triple play, TV, internet, and phone. So we go in and we put a switch in each closet on each floor and do Ethernet to the unit or optical to the unit, and then use CCRs at the top to provide all the firewalling and NATing that we do. And
so one of your goals is to get high bandwidth to either each building, or bring fiber into a main building and then distribute that to outlying buildings. Is that kind of, or do you normally just have one building you're servicing per property? Or
we use a lot of the rooftops to jump from one building to another. So we might be 2 to 3 links deep on the 60 gigahertz in some instances, but it's not very common.
So the 60 gig allows you to branch off to other buildings pretty easily, and you're in a very urban area, so getting fiber to all these is either not practical or very expensive.
Yeah, and so the return on investment's a lot quicker when you can use a radio link versus a fiber lease line.
Okay. I'm going to pick on a couple people. Adair, where are you?
Not in here. Greg has a question. Greg wants to know the 30-second version of how you tune the radios. I did have a video of the arrows that didn't make it into the presentation due to time. But so on the side of the LHG, they actually have up, down, left, right arrows, and it's a guide on how to turn the radio up, down, left, or right. Also in the command line, it tells you actually a percentage of degree to go up or down, left and right as well. So that is one tool to get you pretty close. And then if you do the link calculation on it, you can have a good idea of what your expected RSSI is and try to get there. We found that turning off the TX sectors through the command line can help do the alignment too, because the beamforming can kind of change while you do it. So you make a small adjustment, and then you might see a big swing sometimes, and then it'll settle down once it figures out, because it's constantly scanning through them all and trying to figure out which one's the best path to take. So we've also seen a lot of improvement in the firmware over time with the alignment, and then now have the alignment mode, which reduces the feedback loop on the RSSI because it generates traffic across it constantly. So,
being a tower guy over the years, what Miller was just talking about with the arrows and the alignment, that's something that's really unique to Mikrotik, and it's really handy. If you ever aligned a microwave link or something like that, a lot of it is touch. You know, you just have to kind of learn how to do it with the Mikrotik. You know, with those directions, basically, you can tune in a link pretty easily with little knowledge.
No scope required.
Yeah, no scope required. You know, you just kind of follow the arrows. It's kind of, what is it, Dance Dance Revolution kind of deal. Yeah. I mentioned Adair's name. Where are you, Adair? So you use a lot of Mikrotik. A lot of point to point is what you're doing. We got here. I'll give you.
Hello. What do you want me to just explain what we're doing? Is that what you're asking for? Give us how you're using it. Do you want me to come up there? Would that be easier? It doesn't matter.
Sure.
Okay. Well, I mean, we don't have near as big a deployment as Justin does, but I mean, we are using it in point to points, point to multi points. We've got a couple of MDUs where we'll have like 5, or there'll be like 4 to 6 units per building. We'll bring in one connection to one building and then use the point to multi-point to get capacity to each other building. So that's been pretty good.
Yeah, here's
okay,
here's a couple of the pictures that Adair.
My little crummy pictures, yeah. That's a point-to-point from the top of a grain elevator down to the office that we actually service. So they were able to get a gigabit because we had fiber into there. So.
We actually have a couple of point-to-points or point-to-multi-point deployments too. We had a restaurant that we couldn't reach, so we had a WAP 60 on the other building on the other side of the market, and we were able to shoot to that and have that one be the AP, and then we were able to connect to that. So we were relaying across it to hit a building that we couldn't otherwise reach with wireless.
That's actually some of those pictures I see, and that's exactly what we did to get bandwidth to a customer.
One of the questions we always hear is, how far can this go? What's your furthest shot?
I know we have a couple of 700-meter shots for sure, but it's not using Mikrotik. It's using IgniteNet. So
we have several in the kilometer range. 1.2 is the farthest that we go, but we also have really short ones too with LHGs.
Who else, by a show of hands, who else is currently using some 60 gig? Oh wow. Nice. Anybody have some 60 gig success stories to add? What are we doing on time? I know everybody's hungry, probably like me here. But you know, part of this is, hey, how are folks using their 60 gig? You know, I think a lot of people have kind of pigeonholed it into, well, it's a point-to-point, you know, backhaul type replacement. There's a whole lot of other uses. Are any of you supporting IoT devices? Do you have IoT devices on your network? I think by probably next mum, we'll see more hands raised. And I fully expect people will be aggregating like we were talking about with 60 gig.
Hi, my name is Jim Ainge. I'm from Honolulu, Hawaii. I'm the crazy one was on the back page of the June newsletter with the LHG. Yeah. Barely hanging off a ladder. Anyway, that link is 1,473 meters according to what unit is kicking back. And of course, I started with the firmware that really wasn't there yet and seen it progress up to what it is now. The aiming's a lot easier now than what it used to be. I'll tell you that. So it is a lot better. Before it was just RSSI and that was about it. That's actually going to a building called Waikiki Shell. The nice thing about that is that it's only used during certain hours, certain days, so we were given the ability to kind of experiment with that a lot, so it was a real good beta test. From there, we've actually gone to another city and county of Honolulu building, which is called the Blaisdell Center. Blaisdell Center has a total of 185,000 square feet of display area. We're in one hall that's 85,000 of it. And we're using 4 of the WAP 60G APs to flood the floor. So I'm no longer running Ethernet along the roof and dropping it into the booths. What's really good about that is that as the floor plan changes from show to show, we just have to put up a unit there, and that's a multi-point setup. So we can just do it. So it's a good application for that because you stay well within the range. I can't go more than 200 meters unless I start knocking down a wall. And also there's no rain fade obviously inside. So it's actually a great application if you guys have any exhibit halls or anything around. My deal with them was pretty straightforward. I set it up. No charge to them. They just let me have a space. I bring in a line, and I get to charge the people on the floor as they need. And if you're familiar with a lot of these exhibition halls, normally it's like about $1,000 drop to bring in a gigabit line. I don't charge that much. I charge $250, which is still good. And we have shows going through there. Yeah.
Have you tried the 5th channel on that long link?
On the long link, I've tried it for a little while. It works fine. I mean, it's just that we haven't had an event there for a few weeks, so I haven't really had to do much with it. I actually have it on the 4th channel and just leave it there right now.
We saw like a 7 dB gain on ours when we switched to it.
Yeah.
Anybody else have how they're using it other than maybe a point-to-point or some, hey, this made me a millionaire, I want to talk about my Ferrari, or?
No Ferrari, but I just had some questions about multi-point. Distance on multi-point, how many clients it can support, and any rain fade stories on multi-point.
I believe it's 8 clients right now that it can support.
That would be a Giannis or somebody else question, but I want to say 8.
Yeah.
And it's going to go up by firmware later, I imagine. Maybe.
I can't.
Okay.
I can't confirm nor deny that. Yeah, the WAP 60s are targeted around 200 meters right now, but with the 5th channel, you could probably go a little bit further.
We've used them in our downtown areas as we're building fiber out to various infrastructures just as temporary links. So we'll chuck them up. Like I usually have set in the trunk of my car. I've got a lot of stuff in the trunk of my car. Guys, don't look in the parking lot. But yeah, it's they're really great for that because they're especially like the WAP 60s because they're so small. And I'm just trying to shoot across the street. I've literally opened a window, stuck them outside the window, closed the window, because that's weather sealing it, and then it'll just shoot across. If I only need it there for 2 weeks, no big deal. I get the full gig across that link. When the fiber comes up, it's great.
We had a construction site that wanted some network cameras, so we put a WAP 60 up and shot over to the other building, the trailer, and we can stream the video feeds back. Yeah. So
with the LHG stuff, we did a link where customer was apprehensive about microwave, right? This is the stuff I use in my house. So we threw up LHG link. We ended up doing the fiber point-to-point, and they were so satisfied with it by the time the fiber got in that they left it in place. And we've had the fiber fail twice, and the LHG hasn't. So it's picked up and carried the load. We just do BGP.
The performance
across.
is really great on them too, with small packets.
Yeah, and I don't think we talked about how inexpensive it is to keep a set of those on the shelf. It's really easy to do.
Well, thank you, everybody.
Thank you.